Welcome back to my YouTube channel Grand for Mathematics. Today we will show the given differential equation is homogeneous and we will solve the differential equation. The given differential equation can be expressed as dy by dx is equal to dy by dx is equal to x square plus y square by x square plus xy. Let us say this is equal to f of x comma y. Say we call this equation 1. Now what is f of lambda x comma lambda y? So this is equal to, wherever x is there, we have to replace x by lambda x and we have to replace y by lambda y. So x we replace with lambda x whole square plus lambda y whole square by lambda x whole square plus lambda x into lambda y. Here lambda square x square plus lambda square y square, we will take lambda square commonly outside. So lambda square into x square plus y square by, again we can take lambda square commonly outside, and x square plus xy. This is nothing but f of x comma y. This equal to lambda power 0 f of x comma y. Therefore the given differential equation is homogeneous. And now we have to solve it. And there is another method to show that the given differential equation is homogeneous. So we will divide numerator and the denominator by x square. We will get 1 plus y by x whole square by 1 plus y by x. So this we can write in the form of g of y by x function of y by x. Therefore the given differential equation is homogeneous equation. You can write this as 1 plus y by x whole square by 1 plus y by x. We call this equation 1. Now to solve this equation, we have to take, let y is equal to bx. Once you substitute this in this equation, then this will changes to variables and separable form, and we know how to solve that differential equation. Differentiate with respect to x, we get differentiate y with respect to x, dy by dx. This is equal to, this we have to use uv form. So v into differential of x is 1 plus x into dv by dx. Substitute this in 1. We get, or dy by dx, we are going to substitute b plus x into dv by dx. So this is equal to 1 plus y by x. Y is bx, y by x is b. So 1 plus b square by 1 plus b. You have to take b to other side. 1 plus v square minus v square by 1 plus v. So plus v square minus v square get cancels and we get 1 minus v by 1 plus v. So now x into dv by dx is 1 minus v by 1 plus v. dv is the numerator, so we'll bring v this side, x to the right hand side. So this gives dv, this comes to the denominator as 1 minus v, this goes to numerator as 1 plus v. This is equal to dx by x, we are taking x to the other side. On integrating we get, how to integrate now? The degree of numerator and denominator both are same. So we can adjust the numerator. b minus 1 is there. So we'll write this b minus 1 plus 1 plus 1 plus 2 dv. So b plus 1. So I'm expressing this in terms of b minus 1 so that b minus 1 by b minus 1 is become 1 is equal to minus integral dx by x. Now b minus 1 by b minus 1 is 1. So integral 1 plus 2 by b minus 1 dv is equal to minus integral dx by x. Now if we integrate 1 with respect to v, we will get b plus 2 times. If we differentiate b minus 1, we will get dv log of b minus 1 is equal to minus log of x plus constant. But b is nothing but y by x. So this shows y by x plus log of b minus 1 plus 2 times log of b minus 1. b is nothing but y by x minus 1 plus log x is equal to c, or y by x, then we can write log of y minus x by x whole square, x square into x is equal to constant. So y minus x by x, this I taken to top n log m is log m power n, 2s come here, then y minus x whole square by x square, log m plus log n is log mn, c comes. Or we'll write this as log of y minus x whole square by x. So this is equal to c minus y by x. c minus y by x. So we have to find the value of y. So e raised to the power log of y minus x whole square by x is equal to e raised to c minus y by x. So y minus x whole square by x, that is equal to e power c into e power minus y by x. Y minus x whole square, this is equal to, we will have e power c We will replace with some other constant a. So ax e power minus y by x. So this is the solution where a is a constant. So the given differential equation can be expressed in this form: dy by dx is equal to, we will divide numerator and denominator by x. So this will be 1 plus y by x by 1. So this is nothing but, we can write this as g of y by x therefore the given differential equation is homogeneous. Now put y is equal to bx. So what we will get? We differentiate with respect to x, we will get dy by dx. Again we will use a uv form. So b into 1 plus x into dv by dx. Substitute this in equation 1, we get, for dy by dx, you are going to substitute this. So v plus x into dv by dx, this equal to 1 plus y is bx, y by x is b, 1 plus b. Now this b and this b gets cancelled and we get x into dv by dx is equal to 1. Is in the numerator, so we will retain b on the left hand side. So dv is equal to dx by x. On integrating we get b is equal to log x plus constant, but b is nothing but y by x. Or we can write this as y is equal to x log x plus cx. So this is the answer. The given differential equation can be expressed as x minus y times dy is equal to x plus y times dx. So we have to write this in the form of dy by dx is equal to something like that. So that's why you have to write equal, then dy by dx this equal to x plus y by x minus y. Now we will divide numerator and denominator by x. X by x is 1, this y by x by 1 minus y by x. On dividing numerator and denominator by x, so this is a function of g of y by x. We can express this in the form of g of y by x. Therefore, equation 1 is homogeneous. Now we have to solve it. To solve, what we have to do? We have to put y is bx. If we differentiate, what will come? Dy by dx is equal to b plus x into dv by dx. So for homogeneous equation, always we have to take y is vx and dy by dx becomes v plus x into dv by dx. That we have to substitute the given equation. Then that will changes to variables and separable form. Substitute in 1. Dy by dx is v plus x into dv by dx. Then 1 y by x is v by 1 minus v. Therefore, x into dv by dx is equal to, we'll take v to the right hand side, 1 plus v by 1 minus v minus v. So this is equal to 1 plus v minus v plus v square by 1 minus v. So this will get cancelled, finally 1 plus v square by 1 minus v. Therefore, dv is and the numerator dv by, so v minus 1 goes to the numerator and v square plus 1 is equal to minus dx by x. So on integrating we get, if we differentiate v square plus 1, what comes? 2v plus 0. So we can write this as half times integral 2v by v square plus 1 dv minus integral dv by v square plus 1 is equal to minus integral dx by x. So if we differentiate v square plus 1, we get in 2v, the value will be log of the denominator. So log of v square plus 1 minus integral dv by v square plus 1. So it's nothing but 1 by 1 into tan inverse v by 1 is equal to minus log x plus constant. Multiply throughout by 2. 2 times log x is equal to 2c dash. So we will get log of y square plus x square by x square, then plus log x square. So this equal to 2 tan inverse y by x plus constant. So log m plus log n is log mn. So this will become log of x square plus y square by x square into x square. So this get cancelled, is equal to 2 tan inverse y by x plus constant or plus constant. So this is the answer. So the given differential equation can be expressed as y square into dx is equal to minus 2xy dy. dy by dx is equal to y square minus x square by 2xy. we'll divide numerator and denominator by x square. So this will be y by x whole square minus 1 by 2 times y by x. On dividing numerator and the denominator by x square. So this is of the form g of y by x. We call this equation 1. Therefore equation 1 is homogeneous. Put y is equal to vx. So this gives dy by dx is. Substitute this in equation 1, we get x into dv by dx. So this is equal to y by x is v square minus 1 by 2v. V square minus 1 by 2v minus v. So this equal to v square minus 1 minus 2v square by 2v minus of v square plus 1 by 2v. dv is in the numerator, so 2v dv by v square plus 1 is equal to minus dx by x. On integrating, we get, if we differentiate v square plus 1, what we are getting? 2v. So what is the value of this integral? Log of v square plus 1 is equal to minus log of x. Log is there, log is there, so log c. But what is b? B is nothing but y by x. So log of y square plus x square by x square plus log x is equal to log c. Log m plus log n is log mn. So log of x square plus y square by x square into x is equal to log c, or x square plus y square by x is equal to c, or x square plus y square is equal to cx. So this is the answer. So the given differential equation can be expressed as dy by dx is equal to, we will divide the numerator and the denominator by x square. We get 1 minus 2 times y by x whole square plus y by x. If we divide x square by x square, the denominator becomes 1. So this is of the form g of y by x, call this equation 1. Therefore equation 1 is homogeneous. What we have to do now? Put y is vx. We differentiate with respect to x, we get, substitute this in equation 1, we get, so b plus x into dv by dx. So this equal to 1 minus 2v square plus b. So x into dv by dx. When you take v to the right hand minus b, so this get cancels. So you can write minus of 2v square minus 1. dv is in the numerator, so take b on the left hand side, x to the right hand side. This is equal to minus dx by x. On integrating again, so before writing, take 2 outside the integral. So 1 by 2 times integral dv by b square minus 1 by 2, so 1 by root 2 whole square. This is in the form integral dx by x square minus a square form. What is the formula? Formula will be 1 by 2a, a is 1 by root 2 log of x minus a by x plus a. So b minus 1 by root 2 by b plus 1 by root 2. This is equal to minus log of x plus log of constant. So this will be root 2 goes to numerator, root 2 by 4 or 1 over 2 root 2 log of b is y by x. So y by x minus 1 by root 2 by y by x plus 1 by root 2 plus log x is equal to log c. 1 by 2 root 2 log of root 2x is there, here also root 2x is there, root 2y minus x by root 2y plus x. So we can leave like this is equal to log x plus some other constant or c dash c. You can leave like this also. Here given differential equation can be expressed in this form. X dy minus y dx is equal to square root of x square plus y square dx is there. We will take this term to the right hand side. X dy is equal to y plus square root of x square plus y square dx. Now dy, bring dx to the left hand side, dy by dx is equal to y plus square root of x square plus y square by x. Divide the numerator and the denominator by x. We get y by x plus square root of 1 plus y by x whole square. So this is in the form of g of y by x. Therefore equation 1 is homogeneous. What we have to do now? Put y as vx. This gives differentiate with respect to x. Substitute this in equation 1, we get y by x is v plus square root of 1 plus v square. So v gets cancelled. Now dv by square root of b square plus 1 is equal to dx by x. dv by square root of b square plus 1 is dx by x on integrating. So this is in the form of integral dx by square root of x square plus a square. The value will be log of b plus square root of b square plus 1. This is equal to log x plus log c. So we can write this as log of y by x plus is equal to log of cx. Log m plus log n is log mn. Both side log is there, so we can rewrite this as y plus square root of y square plus x square. This is equal to cx. So this gives y plus square root of y square plus x square is equal to cx square. So this is the answer. So the given differential equation can be expressed as dy by dx is equal to something form. We'll write this first. So this is equal to, we have to bring this in the form of y by x. Y by x is the y by x. We have to divide this y by x is b. Okay, this will take together this into y by x like that, and we will divide numerator and denominator by x. So what will come now? Cos of y by x plus y by x into sin of y by x by y by x sin of y by x minus cos of y by x, then this y by x. Now this is in the form of g of y by x therefore equation 1 is homogeneous. So now put y is equal to bx. So this gives dy by dx is, therefore equation 1 becomes for dy by dx, we put this value b plus x into dv by dx cos v plus v sin v by v sin v minus cos v into b. So we can write this as b cos v plus v square sin v by, now take v to the right hand side. This gives x into dv by dx is equal to b cos b plus b square sin b minus b. So minus b square sin b plus b cos b. So v square sin b minus v square sin b get cancelled. V cos b becomes 2b cos b. This becomes now b cos b 2 cos b. So dv by this comes v cos b 2 dx by x. This will go to the numerator. Cos b into dv. Now we'll integrate on both sides. Now if we differentiate b cos b, what will come? B into minus sin b, one minus sign is there, plus cos b into 1. So if we differentiate this, we are getting numerator with the minus sign. Integral cos b minus b sin b by b cos b dv is equal to minus 2 times integral dx by x multiplied by minus sign. Now if we differentiate this UV form, b into, if we differentiate cos b minus sin b, so minus b sin b is there, plus cos b into 1, cos b is there. If we differentiate the denominator, we are getting the numerator. The value of this integral is log of denominator b cos b is equal to minus 2 times log x plus log c. Take this term to the left hand side. Log of y by x cos y by x plus 2 log x is equal to log c. 2 log x we can write this log x square. Log m plus log n is log mn. So this will be log of y by x into cos y by x into x square so this is equal to log c. So 1x gets cancelled, so we'll get xy cos of y by x is equal to constant. So this is the answer. The given differential equation can be expressed as into dy by dx is equal to y minus x sine of y by x. We'll divide throughout by x. Now this is in the form of g of y by x. Therefore equation 1 is a homogeneous equation. Let y is equal to Vx. This gives a dy by dx is. Substitute this in equation 1 we get. Y is Vx, so V minus sin B. So this V and this V get cancelled and we get dV by sin B is equal to minus dx by x. On integrating we get integral dV by sin B. So we have to 1 by sin B is cosecant V. So integral cosecant V dV is equal to minus integral dx by x. Integral cosecant x dx is log of cosecant x minus cot x plus constant. So this is a log of cosecant b minus cot b is equal to minus log x plus log c. Here also log is there. This term also have log here. So constant we can write as log c. So this is nothing but log m minus log n log c by x. So log of this equal to log of that, so we can write this as 1 by sin b minus cos v by sin b is equal to c by x, or 1 minus cos of y by x by sin of y by x is equal to c by x. So from here we can write x into 1 minus cos of y by x is equal to c into sin of y by x. So this is the answer.